చూపి Okay, good evening. Am I audible?
Yes, sir.
So do you have in doubt from last class?
Yes,
Atif?
sir.
Okay. I will take your Viva at the end of the class, okay?
Okay, sir.
In last class, I defined you zeroth law, which defines concept of temperature. Next is first law of thermodynamics, which is based on conservation of energy. Suppose you have any vessel enclosing ideal gas So what will happen if you supply heat to a particular substance? And similarly, if you ejected or if you have to eject out some heat from a particular system. So in first part, the amount of heat supplied to the system must be utilized in two different processes. First, to expand this piston from some initial volume to reach at this point. So there will be expansion of gas or there will be some work done by the system. And next, this amount of heat supplied may be utilized to change its internal energy or change its temperature. In second part, suppose you have to extract heat. So there will be work done from outside to compress it. And there will be also decrease in internal energy or decrease in its temperature. So we can say first, due to conservation of energy, energy cannot be created and not be destroyed. It simply transforms from one form to another. So in this part, the amount of heat supplied or ejected must be utilized in two different processes. First, to change its internal energy, and second, to do some useful work. Is it clear?
Yes, sir.
Abhinav, is it clear?
Yes, sir.
Energy. It transforms from one form to another. And using this, you'll say the amount of heat ejected or supplied to the system must be utilized in changing internal energy as well as work done. So dq equals to du plus dW. dq is heat, du is internal energy, and dW is work done. Yusuf, in it out?
No, sir.
Okay, just write it down. Yusuf, done?
1 minute, sir. Done, sir.
Okay, now on the basis of these three different terms, heat, internal energy, and work done, we may define into two different parts. First is state function. All the physical quantity which depends upon initial and final point of gas. It will be independent of path followed by the gas are termed as state function, such as internal energy and entropy. So state function is the quantity or the physical quantity which depends upon initial and final point. It will be independent of path followed by gas is termed as state function. So using this, let me define you how to calculate internal energy. So internal energy equals to N number of moles times R universal gas constant times change in temperature divided by gamma minus 1. In terms of degree of freedom, it will be F by 2 nR into dt. In terms of pressure volume, it will be PIVI minus PFVF divided by gamma minus 1. I'll define you later how I have just derived these formula. Okay. Atif, is it clear? Now, you'll be asked on the basis of graph, suppose you have any curve, this, this is pressure versus volume. Let's say along first path, it is going along this way. In second path, this way. And third path, this way. First, second, and third. So it is initial point and is some final point. So you'll be asked, what will be change in internal energy for these three different paths? Let's say along first path, change in internal energy is delta U1, du, du2, and du3. So you'll be asked how these three different quantity will be related with one another. So according to above concept, for change in internal energy, since it depends upon only on initial and final point. So for this curve, we have seen initial and final point. So change in internal energy along these different paths must be equal to one another. So this term must be equivalent with one another. Is it clear? Yusuf,
Yes,
any
sir.
doubt?
No, sir.
Now suppose if you'll be asked to calculate for any closed path, let's say this path, since in this path you'd have same initial point and same final point. So if you subtract those two different points, initial and final, you'll get nothing but 0. So for any closed path, change in internal energy will be 0. This is sign of integration. And if it is defined for any closed path, there will be notation like this. So it will be termed as closed integral or integration for closed path. Abhinav, any doubt?
No doubt, sir.
Okay. Now, next thing will be sign convention for this internal energy. If temperature of system is increasing, so change in internal energy in this case will be positive. And if temperature of system is decreasing, so change in internal energy in this case will be negative. Okay, just write it down to this part.
So what is gamma?
I defined you in last class. What do you mean by gamma? Just 1 minute. Just see this. What is gamma? It's the ratio of a specific gas or specific gas ratio related by F, that is degree of freedom. Atif, is
Okay,
it
sir.
clear?
Understood, sir. Yes.
Okay.
Sir, can you scroll up for a second?
Just 1 minute. This part?
Yes, sir. Done, sir.
You all have written up to this?
Yes, sir.
Okay. So this is all about how to calculate change in internal energy. Next is path function. Those physical quantity which depend upon path followed by the gas, like heat, work done, are termed as path function. So the physical quantity which depends upon path followed by gas are termed as path function. So in this part, we have two different terms. One is heat. So dq equals to n times c times dt. This c will change according to different process, and this is nothing but molar specific constant. So related to each different process, you'll have different value of C, and hence you'll have different amount of heat supplied or ejected to that particular system. Next, for sign convention, if heat is being supplied to system, then it will be termed as positive. And if it is being ejected out, it will be termed as negative. Atif, is it clear?
Yes.
Abhinav, in and out.
No, sir.
Next is how to calculate work done. Work done is simply force times displacement. Force in terms of pressure, it will be pressure times area times displacement. Area into displacement will give you volume. So it will be P dV integration. This expression is nothing but product of any two different quantity, pressure and volume. So related to graph of pressure and volume, area under pressure volume graph will give you work done. Riba, is it clear?
Yes, sir.
Now let me define you different sign convention and processes related to this work done. In first part, If suppose work is done by the particle of gas on this piston, so it will tend to increase its volume from some initial point to some final point to this point. So if you plot graph related to this part, you will get expression curve like this. So this will be initial volume, final volume, volume, pressure. Let's say this is point A, point B. So if you extend this direction of arrow, it will be along this way, and this way. So it is defining clockwise curve. So we can say volume final is greater than volume initial. So difference of volume in this case will be positive, and hence work done will be positive. Atif, is it clear?
Yes, sir.
Which source is doing work? So you will say that is system, that is gaseous particle, to expand piston from some initial volume Vi to some final volume Vf. So we can say work is done by the system. Next, during this process, since volume is increasing, so we can say expansion of gas. Next, if you look the direction of graph related to this process, it is in clockwise direction. So graph is clockwise direction. Yusuf, is it clear?
Yes, sir.
Similarly, let's say for a vessel, initially at this point, so if work is done by any external agency to this piston, what will happen? You will say there will be some decrease in its volume from this part to this part. So if you plot a graph related to this, you will get a curve like this from some initial value to some final value. And direction of curve, if you extend it like this, so this is along anti-clockwise direction. So it will be initial volume, final volume. So in this part, we can say final volume is less than its initial volume. So change in volume isn't negative. So work done in this case is in negative. Which agency is doing work on this particular process? So you'll say some external agency is doing work to compress it. So we can say work is done on the system. And during this process, volume is decreasing. So we can say compression of gas and graph related to this process is in anti-clockwise direction. Abhinav, is it clear?
Yes, sir.
Okay, just write it down. Rishan, done? Okay. Yusuf, written?
No, sir, writing.
Okay.
Done, sir.
Okay. Now, related to these three terms, let me give you some question and define you how to solve. Let's say this is pressure versus volume graph. Like this, whose one end is at this point, next end is at this point, V naught, 3 V naught, one at this point, P naught, and the next is at this point, 3 P naught. And the graph is in anti-clockwise direction. So from graph, find first work done, second heat supplied or ejected out, and third is internal energy. Atif, how you calculate the area of this particular curve? Riba, Abhinav, you must have learned about area of circle. So it was pi r square. But the problem is which radius you will take, along x-axis or along y-axis. So in physics, we generally use for any curve, area will be equals to pi r1 into r2. R1 will be radius along x coordinate and R2 will be radius along y coordinate. Atif, is it clear?
Yes.
So just calculate R1, R2, use this formula, you will get work done. Then use first equation of motion to find the rest of the term. Try to solve all of you. Any problem while solving? Let me solve. Let's say for the x-axis, from this point to this point, it is behaving as a diameter. So R1 will be equals to 3V0 minus V0, that is diameter. Divide by 2, you'll get radius. So it will be V0. Similarly, R2 equals to 3P0 minus P0 divided by 2. So it will be just P0. So work done will be pi R1 into R2. R1 is P0, R2 is V0. So it will be pi P0 V0. Atif, is it clear? Riba, any doubt?
No, sir.
Now just tell me, what will be the sign of this work done? Positive or negative?
Negative.
Good. Since this particular curve is in anti-clockwise direction, And the above part I define you. If graph is in anti-clockwise direction, it will be negative. So work done in this case is negative. Since this is closed path, so change in internal energy for any closed path which I have defined above will be 0. So use first law, dq equals to du plus dw. Du we have 0, so you're left with dq equals to dw, and which is minus of pi p naught b naught. This negative sign for heat will define you heat is being ejected out from this system, or you say there is compression of the system. Abhinav, is it clear?
Yes, sir.
Okay. Yusuf, in and out?
No, sir.
Yusuf, done?
Yes, sir.
Okay. This is pressure versus volume. There is path from A to B and then C. Next, A to D and then C. So along path ABC, if 100 joule heat is supplied to the system and 20 joule work is done on the system. Now, along path ADC, if 10 joule work is done by the system, find heat supplied. Now just look, we have in this particular curve, same initial point A and same final point C for both these two different processes. One is along ABC and the other is along ADC. So if initial and final point is same, you will say it will have same internal energy. So for path A, B, C, write first law, put the values according to the given in the question, then try to find change in internal energy. And then again, put this value of change in internal energy for path ADC, you will get heat supplied. Try to solve and just keep in mind about the sign convention. In first part, we have 100 joule heat supplied to the system and 20 joule work is done on the system. In second part, we have 10 joule work done by the system. Now use sign convention, try to find the required part.
Sir, can you show the previous question's answer? I had some problem.
Yes, Atif. Tell me your problem.
No, sir, I had some technical problems. That's why I couldn't write
Okay,
type
okay,
the
okay.
solution. Yes, sir, I took a screenshot. Now I can solve it.
Atif, any problem while solving? Let me solve. In first part, we have 100 joule heat supplied to the system. If heat is being supplied to the system, it will be taken as positive. Change in the energy we have to calculate. And how much work is in this process? 20 joule, and it is done on the system. So what will be its sign, positive or negative? Riba?
Negative.
Good. Minus 20. Move this minus 20 to left side. So change in internal energy, you will get 120 joule. Now put this value in the second expression. Work done in this case is 10 joule, and it is done by the system. So it will be positive or negative?
Positive.
Good. So in total, you'll get 130 joule. Yusuf, is it clear?
Yes, sir. Clear.
Okay, just write it down.
Done, sir.
Rishan, any doubt? Okay. So this is all about the basic concept of this thermodynamics, internal energy, work done, and heat. Next is thermodynamic process. First is isobaric process. Iso means same, bar defines your pressure. So it is also called Charles' law. The process which is carried out at constant pressure is called isobaric process. The process which is carried out at constant pressure is called isobaric process. So P in this case is constant. So if you write ideal gas equation, PV is equals to nRT. So if P is constant, volume and temperature should be directly proportional to each other. So volume directly proportional to temperature. Now move this volume and temperature to one side and rest of the term to other side. So volume divided by temperature equals to N into R divided by P. So the ratio of volume and temperature for any first system or first process would be equals to ratio of volume and temperature for second value. Since pressure is constant, number of moles will be same and R is same. So V1 divided by T1 equals to V2 divided by T2. This will be termed as equation of state. Now, if you compare this expression using this, so in this part, we have constant pressure. So what will be the value of X so that this volume part will get vanish out. So you say x must be 0. So if you put the value of x to be 0 in the expression of molar specific heat, molar specific heat at constant pressure, it will be Cp equals to R by gamma minus 1 minus R by x minus 1. And since in this part, x is 0. So if you put the value of x to be 0, you will get gamma times R divided by gamma minus 1. And if you replace gamma in terms of degree of freedom, you will get 1 plus F by 2 multiplied by R. Atif, any doubt?
No, sir.
Now, related to any different process, we may define curve, 6 different types of curve, 3 for expansion and 3 for contraction. Let me define only for 3 process, that is only for expansion. This is pressure versus volume. This is pressure versus temperature. And this is volume versus temperature. So in first part, since we have constant pressure, so graph will be a straight line parallel to x-axis. So initial part or initial volume will be at this, final volume will be at this. So area under this graph will define you work done. In the next part, since pressure is constant, so it will give you again straight line parallel to x-axis. In third part, since volume and temperature is directly proportional, so graph will be a straight line like this. So according to ideal gas equation, PV is equals to nRT. Move this temperature to left side and pressure to right side, you will get volume divided by temperature equals to nR divided by P. So this quantity will define you slope of this particular curve, and it should be inversely proportional to pressure. So greater the slope of this particular curve, it will have smaller pressure. Atif, is it clear?
Yes, sir.
Okay, just write it down. Yusuf, Dan?
The last two diagrams.
Okay.
Done, sir.
Now, related to this PV curve, first, we may define slope of pressure versus volume graph. Since graph is straight line parallel to x-axis, so its inclination will be 0. So dp by dv will be 0. Using this expression, you will get the value of bulk modulus beta equals to minus of dp by dv multiplied by v. Since dp by dv is 0, so this particular quantity will be 0. It means there will be no elastic behavior of gas in this system or in this process. Next, related to this PV curve, you will be asked to calculate its volume. So next is work done. Work done is area under pressure volume graph. Since pressure is constant and volume is changing from initial to final. So if you expand this, you'll get P times V final, P times V initial. PV is equals to nRT. So it will be nR some T final minus nR T initial. Take out n into R as common. So you're left with T final minus T initial. So work done may be calculated using this part related to pressure versus volume graph, or maybe using this for change in temperature if they will be given. Atif, any doubt? Abhinav, is it clear?
Yes, sir. Clear, sir.
Okay. Now, since this process is isobaric, it means at constant pressure. So what will be heat? dq equals to n times c dt. Since this process is isobaric, so c in this part will be Cp. Put the value of Cp, you will get amount of heat supplied or rejected in this particular relation. Now let me define you relationship between these three different terms, that is heat, work done, and change in internal energy. Just remember, dq will be equals to gamma times tu, which is equals to gamma divided by gamma times 1 dw. So if you calculate one of the quantity, let's say work done, by PV graph, you will be able to calculate change in internal energy, heat. Now, question is how I have just derived it. Let me define you. In the above part, I have defined how to calculate internal energy. It was N times R dt divided by gamma minus 1. In this part, work done heat supplied is N times Cp, and Cp is gamma times R divided by gamma minus 1 dt. If you divide these two parts, the rest of the whole term will cancel out. You're left with just 1 by gamma. So on rearranging, you'll get heat equals to gamma times du. Atif, is it clear?
Yes, sir.
Riba, any doubt? Okay, just write it down, all of you.
Done, sir.
For helium, PV graph is given. PV graph or any graph related to this process will be also termed as indicator curve. or indicator diagram. This is P, V, initial point, first find work done during this process. Use 1 atm equals to 10 to the power 5 Pascal and 1 centimeter cube equals to 10 to the power minus 6 meter cube. Second, if temperature at A is 27 degrees Celsius, find temperature at B. Third, find heat supplied. First, try to calculate work done related to this graph. For first part, work done equals to pressure V final minus V initial. Put this value. First, convert each quantity in their SI unit and then try to simplify. For second part, use V1 divided by T1, V2 divided by T2, equation of state. Convert each quantity in their SI unit and then put their values to simplify. Atif, you got any answer? Yusuf?
Writing, sir.
Abhinav, any problem while solving?
No, sir.
Tell me the value of pressure in this case. Two atm. How to convert into terms of Pascal? Just multiply it by 50. Initial volume and final volume. Final volume is 50. Initial volume is 20. And since both are in centimeter cube, so multiply it by 10 to the power minus 6. Just simplify it. 50 minus 20, 30 into 2, 60. 10 to the power 5 and 10 to the power minus 6 minus 1. So it will give you just 6 joule. Abhinav, is it clear?
Yes, sir.
Similarly, for the second part, we have to calculate temperature at point B. First, V1, that is volume at first end, 20 into 10 to the power minus 6. Temperature at first end, that is A, is 20 degrees Celsius, 27 degrees Celsius. Convert it in terms of Kelvin. So it will be 300 Kelvin. Volume at B, 15 to 10 to the power minus 6. Divide by temperature at B, we have to calculate. So just simplify it. So TB equals to 50 into 10 to the power minus 6 multiplied by 300 whole divided by 20 into 10 to the power minus 6. 10 to the power minus 6, 10 to the power minus 6 will cancel out. This part and this part will cancel out. 5 into 3, 1500 divided by 2, it's 750 Kelvin. Atif, is it clear?
Yes, sir.
Just tell me, what would be the nature of gas helium? Monoatomic, diatomic, triatomic? Riba? Helium is monatomic, diatomic, triatomic?
Monatomic.
Good. And what will be the value of degree of freedom for monoatomic? Helium is monoatomic. So it will have 3 different degree of freedom. So F will be 3. So gamma in this case will be 1 plus 2 by F. That will be 5 by 3. Put this term in this expression. So dq will be equals to 5 by 3 divided by 5 by 3 minus 1. That will be 2 by 3 multiplied by work done, that is 6 joule. So 3 and 3 cancel out. 5 into 6, 30, divide by 2, it will be 15 joule. Is it clear to all of you?
Yes, sir. Yes, sir.
Rishan? Okay. Just write it down.
Done, sir.
Atif, any doubt? Okay. You all have written?